Hi, good afternoon. As you said, I'm Mike from Intel. I've been working in the space just for the last year or so. When I was presented with the project of working on the new interface, it was kind of exciting. I did it and got things working in-house, and they asked me to do this, so here I am today. Once again, I'm working from Intel, so you'll get to see these again. This is kind of the topics I'm going to go on. It's one of the things that it is a journey. So I went from the place where I got the original code, trying to figure out what's going on and how to make it work, and how to make it work for what we wanted it to do, or at least what we need to at this point. As you probably all are familiar with, there's the security concern with the current ABI, where we use write interface to pass stuff back and forth. A lot of information on that. The workaround Jason Gunthrop actually implemented, and they decided that the new solution was that we needed to use the IOCTL interface, and Matan Barak came up with a pretty interesting solution for that, and they got implemented, and that's what we're working with. The patch for that one was eventually, if you can see the title there, was to add the new IOCTL interface. So there was a patch set that came through, and that was what it was. When I got started on this, I had some code from what actually turned out to be the original patch set that was the RFC rather than the actual one. So I did a bunch of stuff, and I tried to apply it to the current code, and nothing worked. So I had to go back and figure out what I was doing. So looking at the thing that I discovered was that monitoring the email list was very, very important for making sure that this particular thing was working well. In addition to that, there was, this is a work in progress. So as you're working along, the first patch set that I had was doing interesting things, and when I tried to apply my stuff to it, I started getting some weird behavior, like bug and warning and things like that. So I was able to contact Matan, and he was actually said, "Oh, I know about that. Here you go. Here's the right answer." And so these are things that came out and made it a kind of an iterative process to get to where things were working correctly. One of the first things that I started discovering was that we have this new thing. It's a new domain-specific language that Matan has defined using macros. And trying to get to understand that was difficult at first, but as I started working with it more and more, a lot of the decisions that he made on how to do this became more and more obvious of making this a good thing for describing how things are supposed to work and how to expand and work on with the new interface. As I was doing this, I was compiling all these macros with all my different changes in them, and I was getting lots of different, different errors that were making my life interesting and difficult. And I just wanted to share them with you. Probably go through most of them pretty quickly because you can use this for a reference if you ever come back to it. The one thing that I discovered first was that some of the data structure or some of the macros require a minimum size data structure, and I'd never really run across one of those before, so when I got this particular compiler error, it took me a little while to sort out. And the fun thing about these is that you don't get one line that means where the error is. With the macros, you get lots of lines. And so you have to really look at them closely and discover what was going on when that macro was being compiled. This one was simply I missed a size of. Is that right? Yes. So I was actually trying to use a U64 and the data structure, and what you really needed to use was a minimum size data structure that you can use later. So little subtle intricacies in the macro definitions that you have to pay attention to. Another one that I ran into was that some of the macros were using size of and some of them were not. And there's a new set of patches that have come through that may have fixed this at this point, so hopefully you won't yell at me with this. But one of the things you want to make sure of is when you're looking at these macros, make sure that you know whether you're supposed to use the size of or just the plain structure itself. And this one was another interesting one that turned out to be the fact that I was missing an ampersand. So that one took me a little while as well. Last one with that was another one with an ampersand, and it was just in a different location. So if you happen to be doing these macros and you're doing this stuff, you can look back on this and hopefully it'll give you quick information of where you can look for that. And the last two were the missing parameters. This one I actually spent a lot of time on trying to decipher because the thing wasn't very informative. Turns out what I was missing was one of the tags in the list there. And finally, this one was actually good. It told me that I was missing an argument. And sure enough, I was. The next thing that I had to learn that if you guys have been doing the uverb stuff, or the verb stuff, you're probably familiar with, but I was not familiar. The data structures are layered a lot. So you have your basic object that needs to have an IB object in it, and when you ask it to give you objects and stuff like that, it will give that with the layering, and you need to access them using the container of thing that you can get from the kernel instances. And so that once you figure that one out, the rest of it falls out neatly. You can then figure out where your data is and the data structures that are being allocated, and life gets a lot better. Okay. There's a pretty interesting thing that's been put in as an optimization for the pointer in macro. Because we got these nice big data structure or pointers on the 64-bit stuff, there's actually enough information there that you can pass real data in on that particular data structure. And the optimization is that if your data structure fits, or if it's just data, you have to make sure you copy that into it rather than using the pointer. And this one took me I think I had a conversation with Matan on this one. We finally figured out what I was doing wrong. And this is actually code that I wrote for my helper functions. So when you're setting attributes of the different pieces for the methods that are going in, we pass the data in. Once again, if it's smaller than smaller or equal than, an actual data size or a pointer size, then that data actually has to be mem copied into that area rather than using that data. Oh, the other thing, these are, if you look at the uverbs copy from functions, they do the opposite of this. So that's where I was able to sit down and figure out what's going on. Oops. All right. Now I got everything compiled. Life was good. Went and looked at my linker errors, and I discovered that I was missing a bunch of symbols. And this is when I contacted Jason Gonthorpe, actually, and he said, oh yeah, the initial release of this, we did not have any export symbols on the RDMA core areas. And the big important one was the uverbs default objects, which is the one that's shared that has the default stuff for everybody to use. So I had to get my export to export that particular thing, and the newer stuff there's actually been a couple of patch sets that have come out that have a couple of the other ones that are now exported as well. So the last two that I have on there, I had used originally in some of my test code, and then later on I discovered I didn't need them, so I didn't have to do them. But I think that over time, as more and more of the RDMA core is being used for these verbs, because there's a lot of good stuff in there for making stuff work, we'll probably see a lot more things that will become exported. So I got all my stuff compiling. I was all happy it was linking. I went and tried to use the IOCTL interface and discovered that it didn't work. And so I went to the example code, and the difficulty with this was there was not a whole bunch of example code. And the other difficulty was that there's a lot of code there, but there's a lot of things that are unfinished. And they're working on that, and that's clearly being made progress on. So if you sit down to do this, all these things are starting to come to fruition. So I had to use my own test code to try and figure out how to make this stuff work, and that's where I ended up going with this nice enval after my first attempt at trying to contact the verbs infrastructure and touch my very first object. So I had to look around a little bit, and eventually the exciting thing, I found this little one piece of code that said either I had to have a context or I had to be creating the root flag. And so I went looking for the root flag and discovered that it was in fact defined in the macros, but it wasn't in any of the standard types. And was trying to figure out exactly what that was. And the question that I pose is, who's going to create it? And the answer was, you have to do that through the right interface currently. So some of the things are there for the IOCTL, some of the things have to be done through the right interface. So when you're doing your testing, you have to kind of mix and match the two together. And so I decided that I was going to create my own get context interface here. So looked at the current one, was able to refactor the information out of it, pick the command stuff from the right interface that was relevant for the octal interface, and then quickly write a little routine after defining my method. Whoops. And there was the handler that I had to do. The very bottom part is the common code that's split between the two context things. And now I had an IOCTL interface that was, or I had a method from the IOCTL interface that allowed me to create contexts. So geared up with that, I went on to my next problem where I discovered that I cut and pasted a whole bunch of code and didn't adequately name my enumerations for naming all the different objects, methods, and the attributes. And this quickly led to confusion because when I tried to access one object, I was actually getting response from a different object, and that was causing me a lot of strife and grief. So the thing that I did is I went back and I explicitly made sure that I named everything in a certain way with a certain pattern so that I could definitely look at the macro and say, oh, wait a minute, that one doesn't really match. This needs to be something else. And the recent patches that have come through the core have actually done exactly the same thing. And I was a little bit gratified to find that I had the same naming convention that they were using. So I put it in. You want to call your objects, your methods, your attributes. Make sure that you put them in there so you can really see them. So when you actually put them in all the different data structure or macros, you know exactly what you're looking at. Okay. So ultimately what I wanted to do was we have this nice character device driver that we currently use for PSM. And I wanted to figure out how we could migrate that into the new Verbs IOCTL interface. And so I sat down after learning all this other stuff to see what I could do with that. And it turns out that it wasn't actually that difficult. I sat down and looked at the objects, what methods I would need, the attributes that were going to be associated with those methods, and then I sat down and wrote the code for it. And these are my objects. You can see that I have a nice, I start with my object tree at the bottom. I tried to color code things a little bit here so they're a little bit easier to see. You can see that there's a nice little hierarchy going from the object to the definition of the object to the, I actually have two objects in this case, one for kind of a capabilities information and the other one for the actual creation of the file descriptor that was going to be used. And then this is my method that I described. You can see there's one function that's necessary, one method, and it takes in the other stuff and gives it the nice real information. And basically what I did is I had to redefine my file ops. So instead of having my character device, all of my code in my character device, almost all of it is being reused with this file ops through the IOCTL interface. I had to remove the open because it's used slightly differently. The file descriptor method or file descriptor resource that is defined by the macros creates a new file descriptor for you, so I didn't have to have the open anymore. I did have to change the close slightly, so I got rid of one and modified one. All the rest of them stayed the same. This is effectively the open, so when you have a file descriptor object, the infrastructure will call this function. When somebody uses the Verbs IOCTL and it's deciphered, I guess is not the right word, but it gets discovered where it belongs and who it belongs to and how to get to it, it calls this function. You can get the attributes out of it. In this case, I just had the one. Some of the magic that happens while you figure out where your file information is. The core took care of creating the file descriptor for me and pointing stuff to it. The one problem that I ran into was that the file descriptor that's being created by the core has a file data that is part of the file descriptor, and of course I need to use file data for my internal stuff, so I had to do a little mucking around with that people probably scream at me when this comes out, but we'll have to deal with that. And then I eventually just called the HFI open call, which is our internal device core, dev core open routine. Close is a little bit, is pretty close to the same thing. I was able to call my close function, which is able to take down all my internal stuff. And then finally I had to reset the private data so that it was going to be able to be used by the verbs core thing, and they then call the uverbs close file descriptor. And that cleans up the internal data structures for the objects, and you're all done with your particular instance. So it's been an interesting project for me. I haven't been able to spend as much time on it as I'd like to, but I know that there's new stuff coming out that Matan's been working on. So the one thing that I've been taking out of this is that you really have to pay attention to the mailing list. There's a lot of stuff still going on, a lot of stuff that's being implemented, a lot of new features that are going to be involved on this. And he's also been working on other stuff that's going to make some of the type safety better, I believe, and make it a lot more useful for doing other things. So make sure you pay attention to the mailing list. The macro language is challenging to start with, but after you sit down with it and work with it for a little while, it becomes pretty easy to use and understand. Like I said, make sure your enumerations are well named, otherwise you'll have headaches that you won't believe. Weird things will happen, your functions won't be called right. Understand how the data structures are layered. That's a very important piece, so how you get to where your data structures have been added to the overall U objects that they create. And there's going to be more access to the RDMA core over time. And this has been part of a pretty flexible interface to use. I've been having fun with it. It's given me lots of new ideas to add stuff. So as I've been going on, I've been looking forward to getting more stuff to happen on this. And that's what I have. You have questions, comments? All right. Once again, Intel. Thank you very much.